Okay. Hello and welcome to this session of Project Virtual Conference 2018. Today we have speaker Fabian Heisler with us, and he will be talking about the data science meets PM, leveraging advanced analytics and machine learning for project management. Before we get started, I just want to let all the attendees know that you can use the chat option at the bottom of your screen to chat and ask any questions you may have. And without much further ado, handing it over to Fabian Heisler.
Okay, thank you very much. And hello and welcome everyone to this session. It's called Data Science Meets PM, leveraging advanced analytics and machine learning for project management. So in the next 40 to 50 minutes, I want to show you how you can use state-of-the-art machine learning algorithms to enhance and support your project planning. But don't worry if you're not familiar with the data science topic at all. Really don't worry. It's supposed to be a beginner session, so I'll give an introduction and I will do my very best to explain the use techniques in a very understandable way. I know it's a very complicated matter, and discussion on these topics often get very heavy on the math and statistics, but as I said, don't worry, you will not see any statistical formulas or mathematical proofs here today. We're concentrating on the appliance of these techniques to project management. My name is Fabian Heisler. I am working with Campana and Schott to help customers make the most out of their data, and of course, especially their project data. That ranges from finding the right way to store and process your data to extensive reporting solutions. And recently, of course, the whole range of advanced analytics, meaning more sophisticated algorithms to discover patterns in your data and making predictions and recommendations based on this data. Now, before we start with the content, you're probably all used to this by now. Thank you to our sponsors who made this wonderful conference possible. I already watched some of these sessions yesterday, but I already have quite a long list compiled of sessions that I need to catch up with. So again, thank you very much. It's, I think, a wonderful idea to have this in virtual, and yeah, thank you. Okay, so let's just have a short look on what I will show you today. I will start with a quick look at how data has impacted project management in recent years. After that, I will give you a quick introduction to machine learning itself, including some stages from simple descriptive reporting to more advanced techniques. And we'll then quickly come to the main topic of today. How can we make the possibilities of machine learning usable for our project management? We will have a quick look at the technologies we are using for the approach that we are presenting, and I will then show you a quick live demo of one of the possible use cases that we built in Azure Machine Learning Studio. After this, I will show you the possible integrations of these machine learning models into your planning process and into your planning software, for example, into your project client, how this could look like. Okay, with that being said, let's start. So, as you probably know, big data and data analytics have both been important topics in the public discussion and, of course, in companies especially. We can see in this graph that even in 2015, so 3 years back now, about 65% of companies used or plan to use big data. In 2017, this number has risen to about 90%, with 52% already using big data in some way. I think it's quite safe to say that this number will continue to rise, and the number of companies that will use big data in their everyday business will continue to rise. Big data can, of course, have a great variety of possible use cases and benefits. But in the end, the essence is, of course, it should help you grow your business and increase the planning accuracy for your business. This should, of course, also extend to your project management. It's probably one of the central functions in your enterprise for your operations and the development of your company. So now let's take a look at how the planning accuracy in project management has developed in that same time frame, and how the number of projects running out of scope, time, or budget, so the classical things that might happen with a project, how this has developed throughout the years with the rise of big data. So you can see from that green line that although we have seen a sharp increase in big data usage, the share of projects that were not finished in scope, time, or budget has really not moved that much. We can even see a slight increase, so the planning is not getting more accurate at all. Now, this survey is based on a survey of this graph is based on a survey of the PMI, the Project Management Institute. If you have a look at some other studies, for example, some of you might know the chaos report of the Standish Group. A lot of you, so you can see these numbers vary a bit, but the general trend that I show you here is very consistent. So it's not a trend at all, more or less. So the lack of development, this lack of development can of course have multiple reasons, but one of the most common ones in our view is probably that companies do not really extend this big data mindset. It's a good thing if they already have that, it's already something accomplished. But a lot of companies do not extend this big data mindset to their project management. They might have their lessons learned and similar processes that try to make experience from prior projects usable for the next project. And they probably have dashboards and reports where they track costs and project progress. But the majority of companies right now does not really use their data beyond conventional reporting. They're not using data to systematically improve and support their decision-making in the course of planning. So while the project manager is on his project plan, he normally has only a limited amount of data available that can help him plan in that process. Now, before you show you one approach on how one could do that, let's just have a quick introduction to what machine learning is. Now, the term machine learning is, of course, not really new. A lot of you probably have a general idea about what that is. It's not really a new term. It's used in scientific research for a couple of decades now. But in the business, the term is really taken off in the last, I would say, 1 or 2 years. So most of you are probably very familiar with data mining, which is sometimes still used as the umbrella term for machine learning and similar techniques. At the core, data mining is concerned with finding patterns and relationships in your data by various means. It could be like a sophisticated digging in your data stores. Sometimes you might have a specific goal in mind, like you want to find out an exact cause for an increase in a number. Sometimes you might do that just in a very exploratory way to maybe uncover aspects that you were not even aware of before you started digging, but that can help your business anyway. Now, machine learning takes that approach one step further. The algorithms in machine learning are specialized in finding very complex patterns with hundreds or more input factors. And that might be the most important point, maybe, being able to predict certain values that the data might have in the future. This is done by training the machine learning model. When you set up such a model, you feed it with training data. So you create your model with data from which you already know the output. So for example, if a task in your project plan is completed on time or not. So this goes as input into the model creation. And this will then train the model so that you're able to make predictions for new projects too. So for data for which you do not know the output. A simple algorithm could, for example, look like this. The model would put all the input factors in an equation and keep assigning different weights to them until the result of the equation would more or less match the desired output as close as possible. Of course, I know for the experts, this is a very simplified way to describe that, and it's just one of the more basic methods to do that. There are more complex algorithms where it's much more complicated than that. Now, this whole process is called the training of the model. And once the model is trained, you can use it to let it predict future outputs. This could, for example, be numerical values like costs or your revenue, or categorical values, for example, a rating of a product. Now, if you keep feeding new values to your model will keep getting better and better in time. And with every prediction it does, and with every result that comes in and that you feed back into the model, your model accuracy will improve more and more. So the longer you have that model, the more you feed it, the better it becomes, the more accurate are your predictions. So this is probably the stage a lot of companies are in right now. They know about the possibilities of machine learning. Maybe they're already using them for certain use cases, are experimenting in some very limited cases. Now, what we call advanced analytics in this slide, so on the right side, is where we at Campana and Schott want to go with companies that we are working with. It's a holistic approach to store, process, and make the data support the business needs. On the one hand, by providing, of course, the usual reporting dashboards and key figures as we are used to it by now. And on the other hand, by enabling a real data-driven decision-making. So by giving the decision makers hints on what the data shows of what might be the best approach. So when talking about data analytics in general, there are some other important concepts you could have heard of. Analyzing data normally starts with simply capturing what is happening at the moment and then looking back at the data afterwards. So you just have singular data points where you don't really make any connections between them. For example, you look at the tasks in your project plan and simply note the delay across all your tasks. Now, what data mining, so the concept to search for patterns in your data made possible, is to connect some of these dots and maybe find relationships with other data from your project. For example, you notice that a certain resource always finishes tasks on time, that your project costs tend to increase when starting projects late in the year, and so on and so on. But diagnostic analytics can only deliver these insights in retrospect, of course. It cannot really look into the future, it always looks back in the past. While these findings can, of course, help you in your future project, it is often enough completely up to you from there to make this information somewhat usable in your project. So to really draw the right conclusions out of this. Plus, for some of the more complex patterns in your data, you might not even be able to discover or to interpret these in terms of consequences these might have for your project planning. For example, when delays are related to a whole bunch of factors that are interconnected. So, I mean, if you have about 2 input factors that is influencing something, it's probably easy for any human to see that. But if you have tens and hundreds of input factors that influence, for example, a task delay, it gets harder and harder to see which factors are really important for that and which are not important. Now, this is where predictive analytics comes in now. It takes these patterns in your data and applies the results to your current planning data and can, by this, show you what will happen in the future. So what the outcome, if you're planning, will probably be with the given inputs from your current planning. Of course, predictive analysis can only give out results with a particular probability. We're still not able to really predict the future. I think we're all working on that, but until then we have to rely on probabilities. So you can only use statistical means and you will receive a result with an assigned probability. But if that assigned probability is about 80 or 90%, then it might be safe to at least consider this in your planning and think of what you could do to maybe prevent that. If you now think this process one step further, you can probably already anticipate the next step. It's called prescriptive analytics. Now, I'm not too happy that this particular term is stuck for this topic because it sounds a bit harsh. It sounds like you have really no decision and the machine takes over and takes over all the decision making for you. That's not, of course, not the case. I think the more fitting term would probably be recommendation analytics. So your model does not only show you the output you would achieve with your current planning, it could also give you a recommendation on what you could do to optimize your planning based on a given optimization goal that you set up for your model. So for example, decrease the time I need to finish my project. To stick with the example used in this slide, descriptive analytics would tell you that a certain task was delayed, for example, by 10 days. Now, diagnostic analytics could now tell you that a certain resource normally finishes his or her task a bit early. And now you're planning another task in your project. And your predictive machine learning model would tell you that with the current plan that you have, your task would probably be delayed by 90%. So given that you now have a couple of factors that you could change for this task, you're probably unsure what exactly you should change to prevent this from happening. Your machine learning model knows about all these factors and how they are related and connected to each other, and can therefore give you the best recommendation on what exactly you should change. So much about the basics of machine learning and advanced analytics. And now let's have a further look on how we think this can be used for project management. So this is our approach to the topic. The basic idea is to merge these two areas and gain more insights than we would typically achieve when we're just looking at project management with the descriptive analytics view that we're all used to by now. Therefore, the goal is to generate new knowledge from existing project data, so data you already have. Like in the scenario on the previous slide, that staffing a certain resource on a specific task can lead to more efficiency. This can, of course, also be utilized for the actual decision-making processes, like whenever additional steps are necessary for the project to finish on time. Ultimately, this approach could be used as an additional tool for project risk management with a full data-driven decision-making approach as a contrast to traditional project risk management methods. Talking about methods, our method to gain meaningful insights from existing project data is to combine multiple machine learning algorithms and methods. For example, you have clustering mechanisms in neural networks, decision trees, and so on. And these algorithms, which algorithm you choose, of course, always depends on the actual business objective and the defined use case you have. Different objective means a different model is suitable for this. So this model always has to be created on a custom level for a specific use case. There's no pre-built model that you could use really out of the box. You always have to adapt that to your special use case and to the special questions the company might have from a business perspective and the challenges it faces. One example would, for example, be to categorize both internal and external input factors from Microsoft Project, like you have resources, your planned duration, actual duration, and for example, cost data from a third-party system. For example, you have an SAP where you have some finance data or some staff data and so on. I want to then use these factors combined to predict one key field, which, for example, could be the outcome of a specific task, whether it is delayed or completed on time. The third element you see on the slide addresses the success factors for machine learning in a project environment. The first success factor is the amount of data which could represent the number of completed projects or the number of completed tasks of a specific type. And of course could also be external data that you have available in external systems, as I just mentioned. However, and I know this question always comes, it's quite understandably so, it's hard to really name a number of how many projects you need to have stored to make this approach work, or how many giga or terabytes of data I need to make that work. It always very much depends on the specific use case, on the specific project environment that you are working in. Another important success factor is, of course, data quality. As for probably every data analytics project you want to do, it's essential that you have a certain degree of data quality to make this work. It basically means that the data has to be properly maintained beforehand, like your planned values and your actuals, or the standard rates set for your resources and so on. But as with the data amount, this also depends on the use case or a business objective you want to achieve. As predicting, for example, a task outcome might require completely different data compared to predicting planning accuracy of single project stages. But generally, the old slogan, of course, applies: garbage in, garbage out. So a certain degree of data quality always helps. The final success factor is the project landscape. It's definitely a plus, but not a must when the model can use a homogeneous landscape, for example, when predicting a task outcome. Now, if you, for example, want to predict whether there will be a delay in a construction project, the algorithm will make use of this data from previous projects. Therefore, the structure, or better, the work breakdown structure, is ideally, at least in parts, comparable to achieve correct results. But machine learning algorithms are generally very adaptable, even to data that seems completely random to us. So it's always you always have to see on the single case what exactly you need in terms of data. Now let's have a look at some of the more possible use cases in project management that we could use this approach to. So on this slide, we can of course only list a fraction of the possible use cases. As I said, enough now, it all depends on the data, on the individual needs of a company and the challenges it faces in their project management. To make it a bit more clear, I chose to separate this slide into the categories that you now know from 2 slides back. It's diagnostic analytics, predictive analytics, and prescriptive analytics, or how I would call it, recommendation analytics. Use cases in the diagnostic analytics area could typically involve the discovery of, for example, hidden relationships in your project data. Now, if you take the point, identify problems for combinations of external and internal resources. From a business perspective, this would be the case when a task is delayed, when, for example, 2 specific subcontractors working for you work together on a construction site, for example, and the tasks they work on get delayed very often. This, of course, leaves room for a lot of interpretation and further investigation. Maybe it's just the communication between these 2 subcontractors is not really working, or there are other blocking points that would require further checking. On the other hand, you can also compare the efficiency between your internal resources and your external resources in a benchmark-like scenario. An easy way to do this would be to compare the average time needed for a specific task by both groups and compare them on a higher level. But if the external resource costs more to you than your internal resource but takes less time on average, you of course need more intelligence. You would probably need you would probably want to discover when it is more economical to make use of the external resource instead of the internal resource, although the costs per hour are higher. So this is a case where machine learning could really help you make the correct decision, as the input factors that go into this decision or in that outcome, that create that outcome, get too complex at some point to really look them through without technical means. So much about diagnostic analytics. When we take now a closer look at the predictive analytics part scenarios, we could use the model to predict the likelihood whether a task or a project will be delayed or finished on time. Therefore, the model will make use of both internal and external factors to improve the prediction quality. Of course, we can also do this for costs instead of duration, if the data is maintained in a way that we could use that for a predictive model. Although predictive analytics can help you make decisions or to improve your project planning, it most of the time makes sense to also use prescriptive analytics to make even more use of your data and to further increase your planning accuracy and quality. With prescriptive analytics, you could accurately set the length of your project phases and the overall project duration, as the algorithm will make use of the projects which you already completed and where these phases have been completed. So it can make, based on these data, make an estimate how long these phases will be and how long you should plan that. Another possible use case would be to predict the, let's call it the perfect resource, the golden resource for a given task. Based on the historical project data, you know how different resources, both internal and external, have performed on a specific task or on a specific task category under given surroundings. When you now utilize this data for a model, the algorithm can be used to predict which resource can increase the speed of delivery for the chosen task under given circumstances, or if a resource slows the task down. This could, of course, be directly used when the project manager is planning the project in his Microsoft project or wherever he plans his project. Now, as I said, this was already only a fraction of the possible use cases, and depending on the challenges a company faces, there are plenty of more where you could use these algorithms to really help you in your project planning process. Now, you're probably wondering now, how can I start with all this? What is my investment that I need to do before I can start reusing this? Well, with the approach that we have developed, you for the start do not really need much more than most of you are probably already using. Let's start with the data sources, so the places where the data you want to use is actually generated. Most of you are probably using a whole range of tools to do your project planning. At the core, most of you, of course, at the Project Virtual Conference, the core, most of you are probably using Microsoft Project, either on premises or as project online in the cloud. Other software solutions are, of course, also possible for this. Now, this is where the majority of your data comes from, for example, the actuals for your previous projects. In addition, you might be using some maybe auxiliary tools that make your life as a project manager easier. If you're using Project Online, you surely have some additional planning data and general resources that help you plan your projects in your SharePoint, for example, lists for your risk management or lists for your lessons learned, etc. For some smaller projects, you might be simply using Microsoft Planner to assign some tasks, and maybe some of you are using Excel or Power BI to calculate some key figures, create some dashboards or some reports that help you in your planning and in keeping track of your projects. Finally, there, of course, could be a bunch of other external tools that are not really directly related to your project planning process, but that have data stored that might be influencing the planning anyway. So, for example, you might have some additional information about your resources or the materials you used, for example, data about your staff in your SAP or whatever. What all of these tools have in common is that you can access this data, for example, via exporting this data or directly via an interface. Many companies might already do that and use this data in a warehouse or a data lake for further analysis and for more complex analytics scenarios. For our approach, this is really not necessary. We can directly tap all of these silos separately and combine them directly when creating the model in Azure Machine Learning. So now that we have that data, we of course need to do some maintenance with it. It's safe to say that probably none of us has impeccable data. There are surely some values missing or values that have been entered not correctly, etc. We all know how that goes once a project is running. So this definitely needs to be addressed in the first step. You cannot just leave these values empty and this data in the format that you directly received it from, because this might seriously mess up with the model if you just put it as an input into the model like that. Now, for example, for the missing values, we of course cannot in retrospect say how the missing value might have looked like exactly. But depending on the other values, it might be best to just exclude these values or simply fill them with the average of the surrounding values. There are a couple of techniques to really address this very common issue with missing data. Furthermore, we of course might need to transform some of these columns. For example, we have to bring data in the right format, find categories for free text values, etc. And finally, it might make also sense to already do some calculations or maybe exclude some inputs from which we know that they will not be needed. Now, for this, you could do that in Excel, of course, for larger amounts of data. It might also make sense to do that directly in the Azure Machine Learning Studio, which we'll have a look at in a couple of minutes. Because from there, you have the possibility to use Python or R, which are two of the most commonly used languages in data science, and that can really help you easily transform large data sets and adapt them to your needs. So after that is, of course, the most important part, the actual creation and training of the model. For this, we decided to use Microsoft's Azure Machine Learning Studio, which is in a basic version available for free. Of course, if you need to crunch a larger amount of data, it might make sense to have this data stored directly in Azure and increase the number of nodes that can work on your project and in the calculation of your model. And this would, of course, then cost something. But with the free version that's available, you can already achieve some pretty amazing results for some use cases. Now, in the Azure Machine Learning Studio, you have a couple of algorithms depending on the type of output you want to produce, for example, a numerical value or a category. All of these value algorithms are ready to use you can just use them out of the box. So you don't have to put in any statistical formulas yourself. The only thing that you have to adjust is some parameters in these algorithms. For this, the Azure Machine Learning Studio also has some tools that can help you find the right parameters. But normally it's an iterative process, and depending on the findings from your data explorations, you compare results of different models and parameter settings. And depending on which model and which parameter setting performs best, this will be the model you choose in the end. Now remember, for the training of the model, we are always using data for which the output is already known, because otherwise the model would have nothing to train on. It needs to know the output in order to generate the functions it needed. It's need to predict the output. Now, if the model is now reliably able to predict these outcomes, your model is ready to be used with real data for which the output is not known beforehand, of course. Now, it's, of course, not very practical if you always have to log into Azure Machine Learning Studio to verify some of your planning data. For this, you can easily set up a web service in the studio, and you feed that web service with your inputs from your planning, and the Machine Learning Studio will give you directly back the predicted outcome via the same web service. So from there, you can easily integrate this into your planning tools and, of course, your reporting tools as well, like Power BI or Excel. We have a separate slide on that topic on how these integrations can look like after the live demo. So I don't want to go too much into detail here. For now, let's finally have a look in how this can look in Project and Azure Machine Learning Studio. And for this, I want to switch over to my project center. So for this example, we have a construction company. They're using Project Online to manage their construction projects. Right now, they have about 800 projects across several project web apps. And these projects are more or less standardized, and they're using the same work breakdown structure template. Of course, there are some deviations. Not every house they build is the same, but most of it is pretty consistent across these projects. The construction company is building residential houses, so the complete package from the foundation work to the interior completion. We can now have a look at one of these projects to get a more detailed view on how this looks like. I can open that in the PWA, or we have the plan open in my project client. Now, this is one of their project plans, and to go just a bit into more details, they're starting with some contractual formalities, then they do their planning and scheduling, and then go over to the actual construction and finalize it with the handover. Now, when you have such a complete set of data, there are, of course, a couple of use cases on which you could apply machine learning algorithms to. In this use case, we want to demonstrate today. So we decided to take a closer look at the heating installation task, which is this one. So this basically contains everything from installing heating pipes, laying underfloor heating, mounting the radiators, etc. Now, our goal here is to predict whether this task will be completed on time or if it will be delayed. For this, we of course need two fields. We need the allocated time, so the planned time for this task, and of course the actual time. This will allow us to calculate the difference and else categorize this task as delayed, or if it's on time, or if we even have a buffer. Of course, we also need some more input data for our prediction. This can be, on the one hand, is stored on a task level. On the one side, the assigned resource or the leg of the predecessor and so on. And on the other hand, this could also be stored on the project level via custom fields. We included these here in that plan just to show you what fields we have here. We have the square meter space of the house, we have the number of rooms, we have the number of bathrooms. We have a field which indicates if a solar panel is installed. And we have one field which indicates if floor heating is installed in the house. So now with this data as the foundation for our model, let's now jump into the Azure Machine Learning Studio to have a closer look at that. Keep in mind, we are now not only using data from one project, but we're using data from all of the 800 projects the company has in their data set, and which has this particular task in there. We can see that right here. This is the imported data set. We can just have a look at this. So it just takes a couple of seconds to load, and we can see we have about 800 rows, which represent the single projects, and we have 21 columns, which represent the input factors for which we are using for the machine learning model. So you can already see the familiar columns, project ID, project name, of course, you have the task ID, etc. And then here you can see the enterprise custom fields that we just showed you. Now for all of these fields, you can directly see some visualizations on the right hand and some statistics that can later help you deal with the data or transform that data to data that you can really use for your machine learning algorithms. Just a couple more words about the general Azure Machine Learning tool, because some of you probably have never worked with that before. It's really easy to use. So you have that modeling canvas here, and you can simply drag and drop modules from this left-hand side into there. For example, you have this import data module, which you can use, where you can just directly import from your Azure if you have your data in Azure, or you can import from some files you might have stored somewhere. You can, of course, also export data. There are some common operations for data transformation. We will have a look at what we are doing here with that. And of course, the most important one for the Azure Machine Learning Studio is the machine learning part, which will give you some of the most important models that are used in machine learning to really train your model and create your model. Now, if you just, you can, as I said, you can just drag and drop these onto this canvas here and connect these with these little lines, and then you have a complete model workflow or a pipeline as you're used to it when you are working with data. So in addition to that project data that we imported, we have now 2 data sets from external systems that we implemented here. For example, we have here this supplier data. Let's have a short look into this as well, which basically just says us for every project idea some additional data that we might have stored in a different system. In this case, it's the number of stories of the house, the length of the pipe that is needed, and the used material for the pipes in a coded format. And for this code of the format, we have another data set included, which basically just really maps these codes to actual values that that can really speak to us. Now these data sources may or more just get joined to form one complete data set, and on top of that, we are also doing some transformations on this data set. For example, we can have a look at one of these here. As you can see right here, if you are not content with the models that you get from the Azure Machine Learning Studio, you always have the possibility to just import, to just use some custom Python script or some SQL transformations. So if you need some more complex data transformation options, this is always an option to just import your Python libraries or your R libraries, which you might be already using when working with data, to just get this data in shape in a really easy way. Yeah, as you can see, we're just doing some transformations. We are transforming some values to categorical values. For example, the material value that we have imported at the top. And then we're just dealing with some missing values and so on and so on. And now the next important step for the preparation of the training of your model is this split data module. As I said, you always need a training model, which we use to train your model, which has known outcomes, and you need some data to really get to know if that model is working for the use case that you have. And for this, you split your data. Normally, you take something like 70-30 or 60-40. So you take one data and use it to train your model, and the other data you use to later validate your model. Now, as I already showed you, you have a couple of algorithms you can use. It's always beneficial to just take some of these, run them in parallel, and see how they perform. Of course, depending on if you need a categorical value or a numerical value, you always have a subset of these available models that you can use. But it's always good to just try out some things. In this case, we took the two-class boosted decision tree model. And when you click on this module, you can see that you have a couple of parameters that you can set. For example, you have here the number of trees that are constructed. And how this looks like, we will now take a look in this train model module, which is, of course, the core of the whole thing. And if we now open this, it will probably take a couple of seconds until it loads completely. You can already see that it generates 100 trees as we defined in the parameters. And it will now show us for all of these trees, it has created a visual representation of this tree. So if you now zoom in here, you can see that based on some of these values that you have in your data, the model goes to the left branch or the right branch, and depending on what values you have there exactly, it categorizes this task as delayed or on time. Yeah, of course. So if you could, of course, it's always beneficial to have a large number of trees, because every new tree that's generated basically learns from the old tree or from the previous tree. But of course, you always have to keep in mind that if you just increase that number to, I don't know, 1,000, the runtime of your model will, of course, increase, and the training of the model will, of course, increase as well. And you always have to keep in mind that when you train that model too much on your training data, it might work very, very good with your training data, but it might not work with the data you experience in real life, because in real life it might be you might have some peaks or some lows, which your training model can then not, which your trained model can then not really cover, because it is too much concentrated on the training model data set. You always have to keep a good balance on between the fitting to the trained data and to keeping the model robust enough to get good values for realistic data sets. So now after the train model, you can see that we feed these values from the train model into that score model, and we also have the other data set from a split data set back in here. So this is the moment where the trained model is compared to this validation data set that we have. Now keep in mind, for this validation data set, we still have the outcomes. Of course, the model will try to predict these outcomes without knowing these outcomes. But this gives us now the opportunity to look into this model and see which value the model would have predicted and which value it actually has in our data that we already have. So you can now see the usual columns. And if you scroll now to the completely right, you see this is our status flag that we have, and that was used to do the prediction. And this is the scored label. So this is the prediction the model really has done. So these are our actuals, these are our predictions. And you can see that most of the time it seems to work. We have here some cases where it did not really work, but in generally we have quite high precision of this model, and we have quite good numbers that we could work with. There's another module in here that can help you evaluate how your model performs, this evaluate model. If you open this, you can get some more key figures on how your model performs. For example, you have these true positive, which are basically if the outcome is on time and the model predicts on time, then this is a true positive. False positives are if your model predicts on time, but the actual value is not on time. And true negative is of course the case where a task is delayed and the prediction is also delayed. There are some other metrics in here, depending on what algorithm you use and what input data you have. It might be worth looking at one or two of these values and try to really concentrate on increasing these. But this always depends on what model exactly you use. So with this model, it's a very simple case, but it generally shows very good on how you can use the really simple model to predict an outcome of a task for which you might not have known the outcome before. I promised you we'll just have a quick look again at how possible integrations into your planning could look like. And for this, we jump back into the slides. And so here are some examples how this could look like. For the use cases, this is of course highly dependent on the needs and the tool set of the customer. Not every customer uses the same tools, but generally it's for every tool that you're using, you can find a way to integrate these predictions from the machine learning model into your solution. Some might want to have that only in their reporting solution. Some might want to have that directly into their planning tools, for example. Now, one of the more simple integrations would be to have a resource recommender. You can see that in the top left. When setting up a task, you might have a couple of available resources to choose from. Now, how to choose the right one? Again, you might have some gut feeling and your experience on who is appropriate, but sometimes it's just nice to be able to validate this somehow. Sometimes you might be a bit tunnel visioned. You lose sight of some other aspects that are important for your planning, some things that might have changed recently that you're not aware of in that moment. In that case, your machine learning algorithm could, for example, warn you if a certain resource would not be the best choice and could present you an alternative that you could choose. Now, this is, of course, only meant as a support for your decision-making process. It doesn't really make the work for you. A more sophisticated integration could be a complete recommendation report, which shows you the whole range of aspects that could be improved in your plan based on your machine learning algorithms. From there, you could also, of course, directly adopt some of these changes if you want to, or you could just use that report to optimize it on some areas. Other integrations could be done, as I said, directly into your reporting solutions in your Power BI or your Excel in your dashboards and reports. And maybe you're tracking costs across your project portfolio, or you're tracking your project progress or the usage of your resources. And instead of only having a curve that shows you the historic data, so what has been in the past, you could now have a quite accurate forecast based on the prediction model that you use. So now let's summarize what we have shown you in this approach that we developed, and just name the key takeaways. So this is really about making your data work for you. With the presented predictive project management approach, it's possible to gain additional insights into the data that you already have. So you generate tons of data in your planning every day. So you should really start using this. Or using the data that you generate. This way you can make use of the projects you already completed and learn from them automatically by using these modern technologies like the Azure Machine Learning Studio environment. By using machine learning methods in a project environment, you can reduce planning inaccuracies and, for example, predict the outcome of a task with a certain likelihood already in the planning stage of the project and not in retrospect. Of course, this way you can reduce the risk before starting a project or a task. It also offers an advantage compared to classical reporting, which would be both descriptive or diagnostic analytics, as you're able to discover more complex correlations and relationships between and inside your projects, inside your task, inside your data. As every project can be added to the calculated model, it's possible to use both projects that have been completed way back and also very recently completed projects. This means that if you keep on feeding your recent project into your machine learning model, it will be retrained constantly with your actual values that you have. If something did not work as planned in a project, the algorithm will keep this in mind and use this kind of knowledge for its prediction. This also means that your model will improve automatically with every finished project, which is loaded into that model. With this way of self-improvement, the model can score better results and, from a business perspective, of course, more reliable predictions. Now, finally, you're able to gain insights that were invisible before. Machine learning models can discover really hidden relationships in your project data, which could not be uncovered in an isolated reporting view, because you can always see a couple of dimensions at the same time, and these algorithms can look at hundreds of dimensions at the same time. On the one hand side, this could be relationships inside the project data itself, for example, like a correlation between a resource and the success of a task. And on the other hand, you can also merge your project data with external sources, which could lead to an increase in prediction quality. Because with more influencing factors that are available, your prediction model will keep on improving. You can also use this approach really to have a foundation for decision making, or so to say, to prove that your gut feeling was right. Sometimes you might think, those two resources seem to work especially well together, or a combination of certain suppliers is working pretty good. And when utilizing this data analytics approach in project management context, you can basically quantify these measures that were only kind of implicit knowledge up to that point. This means that this approach can also be used as a kind of knowledge management to quantify certain beliefs and use them to justify decision, as they are now backed up with numbers. So it can really drive the data-driven decision-making in your company. Okay, that's about it I wanted to show you. I'll be happy to answer any questions if there are any.
Okay, looks like we have one question for you, Fabian. And the question is, what are the possible sources for machine learning? Are there any connectors in Azure to read project data, or everything would need to come from an Azure DB or premise DBs?
No, it does not have to come directly from Azure. You can you can directly connect, for example, an OData feed into this Azure Studio, or you can, of course, do an export of your project data that you have somewhere and store it in a file somewhere, which you could then import there. So there are a couple of options. It does not have to be Azure. I know it's called Azure Machine Learning Studio, but it gives you possibilities to get data in there from other sources as well.
Okay, I don't see any other questions at this time. Thank you so much for your contribution today, Fabian.
Thank you very much.
And attendees, please don't forget to fill out the survey to give us a feedback on this presentation. And thank you so much for joining us. You all have a great day.